Tonight, as the sun dips below the horizon, the greatest threat our planet has ever known isn't a supervolcano or an asteroid. It's an invisible predator, a cosmic void, about to make our world its next meal. This isn't science fiction anymore, not with the way a rogue black hole could suddenly appear, silent and unseen, until its gravitational claws begin to tear at the very fabric of our existence. For billions of years, Earth has orbited the sun, a delicate dance of gravity and inertia, providing the stable conditions for life to flourish. Our moon pulls at our oceans, creating tides, a gentle reminder of the cosmic forces at play. But our solar system is a vast, mostly empty expanse, a comfortable bubble in the otherwise chaotic galactic neighborhood. What we rarely consider is the sheer amount of unseen matter out there. Black holes, born from the collapse of massive stars, are perhaps the most extreme examples of this cosmic invisibility. They are regions of space-time where gravity is so intense that nothing, not even light, can escape. Imagine crushing something with the mass of our sun down to a sphere just a few kilometers across. That's a stellar mass black hole, incredibly dense, incredibly destructive, and potentially moving through space at hundreds of thousands of kilometers per hour. While the nearest known black hole, Gaia BH1, is about 1,500 light-years away and poses no threat, the what-if a rogue one came hurtling our way is a chilling thought. These cosmic cannonballs can be ejected from supernovae or recoiled from black hole collisions, gaining tremendous speeds. They aren't cosmic vacuum cleaners, endlessly sucking in everything around them from vast distances, but get too close and their gravity becomes an inescapable force. So what if one of these stellar mass black holes, say 10 times the mass of our sun, suddenly entered our solar system and set a course straight for Earth? It wouldn't arrive with a bang, but with a ripple. The first sign, long before we saw anything, would be subtle gravitational anomalies. Satellites in orbit might show slight, unexplained deviations. Highly sensitive instruments on Earth would pick up minuscule changes in gravity. So, what if one of these stellar mass black holes, say 10 times the mass of our sun, suddenly entered our solar system and set a course straight for Earth? It wouldn't arrive with a bang, but with a ripple. The first sign, long before we saw anything, would be subtle gravitational anomalies. Satellites in orbit might show slight, unexplained deviations. Highly sensitive instruments on Earth would pick up minuscule changes in gravity. Our meticulously calibrated GPS systems would start to falter, not just in specific regions, but globally, as the space-time around us began to warp. The Earth's orbit, once a perfectly predictable ellipse, would subtly distort, causing tiny yet noticeable shifts in our planet's position relative to the Sun. Over days, these subtle effects would escalate. As the black hole drew closer, perhaps still light hours away, the gravitational pull on our planet would become undeniably strong, overwhelming the subtle tug of our moon and even the Sun. Tides, which are a result of the differential gravitational force across Earth, would become monstrous. Instead of gentle ocean swells, we'd see colossal bulges of water rising miles high, racing across continents, swallowing coastal cities whole. Tsunamis of unprecedented scale would obliterate everything in their path. The crust of the Earth itself would begin to flex and strain under this immense gravitational stress, leading to a relentless onslaught of earthquakes, volcanic eruptions, and massive tectonic shifts. Entire mountain ranges might rise or fall in hours. But the most visually striking phenomenon would be in the sky. As the black hole approached, its immense gravity would bend the light from distant stars, a process known as gravitational lensing. Stars would appear to shift from their familiar constellations, distorted into strange arcs, rings, or multiple images, like looking through a cosmic funhouse mirror. This isn't some minor visual trick. It's space-time itself being warped into an optical anomaly. And then, a growing, circular region of utter blackness would begin to appear, expanding against the stellar backdrop. The silhouette of the black hole's event horizon, absorbing all light, reflecting nothing. Closer still, within the orbit of the Moon, the black hole's influence would become absolute. The Moon itself, our ancient celestial companion, would be torn from its orbit, perhaps flung into the depths of space, or, more likely, ripped apart by the black hole's devastating tidal forces, forming a temporary incandescent ring of debris around the void. For Earth, the situation would rapidly deteriorate. The side of our planet facing the black hole would experience a gravitational pull thousands of times stronger than the far side. This differential gravity is what gives rise to spaghettification, the stretching of an object into a long, thin, noodle-like shape. The atmosphere, once a protective blanket, would be the first to go, vacuumed off into space, leaving us exposed to the harsh vacuum. The oceans would boil and evaporate under the extreme forces the water molecules themselves eventually pulled away. Then, the solid Earth would begin its violent unraveling. Continents would tear apart, not along fault lines, but anywhere the gravitational gradient was steepest. Fissures would open across landmasses, revealing the molten mantle beneath, which would erupt in fiery geysers. The planet would cease to be a sphere. Instead, it would be stretched, elongated, deforming into an ovoid, then a teardrop shape, like clay on a potter's wheel spinning wildly out of control. Imagine mountains stretching into impossible spires, then snapping, their material streaming towards the black hole. The very rock would lose its cohesive strength against the overwhelming tidal forces. We would be witnessing the literal unmaking of our world. As Earth's elongated form hurtled towards the event horizon, the point of no return, the view would be terrifying and mesmerizing. Gravitational redshift would take hold, causing any light emitted from Earth, if there were still any coherent light sources, to shift to longer, redder wavelengths, eventually fading into invisibility for any distant observer. From our perspective, falling into the black hole, time itself would appear to slow down for the outside universe. We would see the universe outside accelerating into the future, becoming a blur, before fading entirely as we crossed the event horizon. The actual crossing of the event horizon for a stellar mass black hole would be abrupt and catastrophic. While for supermassive black holes, you might cross the event horizon without immediately feeling spaghettification, a stellar mass black hole's tidal forces are so powerful they would rip you apart long before you even reached that boundary. The Earth, by this point, would be a river of superheated plasma and atomic particles, stretched thinner and thinner, as if pulled through an invisible cosmic taffy machine. Every atom, every molecule, every fundamental particle that once made up our world and everything on it would be stripped apart, separated, and drawn inexorably towards the singularity, the infinitely dense point at the heart of the black hole. There, all matter, all information is believed to be crushed out of existence, lost forever. What would be left of our solar system? A new, silent gravitational anchor. The black hole, having consumed Earth, would continue on its trajectory, or perhaps settle into a new orbit around the Sun if its velocity was low enough. Either way, the gravitational balance of our solar system would be irreparably shattered. Other planets like Mars, Jupiter, or Saturn might be flung out of the solar system entirely, tossed into the cold, dark expanse of interstellar space, or dragged into new, highly elliptical and unstable orbits. Collisions between the remaining planets and asteroids would become far more likely. The Sun itself could even be perturbed, its life cycle potentially altered, though it's too massive to be easily swallowed by a single stellar mass black hole. The beautiful, intricate clockwork of our celestial home would be forever broken, a stark monument to the power of a cosmic encounter. So, if a black hole swallowed Earth tonight, it wouldn't be a quick, silent disappearance. It would be a drawn-out, agonizing cosmic ballet of destruction, an unmaking of everything we know, from the ground beneath our feet to the air that fills our lungs. Our stable world, a vibrant oasis in the cosmos, would be stretched, torn, and finally rendered into a mere memory, a whisper of radiation swallowed by an eternal void. It serves as a stark reminder of the fragile yet spectacular existence we inhabit, poised within a universe capable of both incredible creation and unimaginable annihilation.